For this demonstration, I'm using these really cool switches that Aruba sent me. They support 1 gigabits per second, 2.5 gig, 5 gig, 10 gig, 25 gig, 50 gig, and 100 gig. It's really nice to be able to demonstrate the configuration of Aruba devices using the latest switches from Aruba. This lab costs about $100,000. Now, don't worry, you don't have to go and spend that kind of money. In separate videos, which I'll link below, I'll show you how to run Aruba devices for free on your laptop using GNS3. Now, if you want to see all the videos in this series, use the links below. Okay, let's get started. Now, in the previous video, I configured these ports on the switches as access ports. They are all configured in VLAN 1. Typically, what you'd want to do is configure these as trunk ports so that you can allow multiple VLANs across the ports. The term that's often used is trunk or tag ports. That allows multiple VLANs to traverse these links. The reason you want to do that is, as an example, we may want to put one PC in VLAN 2 and another PC in VLAN 3. Or we want to have both those PCs in the same VLAN and we want traffic to be able to go across the core network from one PC in one VLAN to a PC in another VLAN. Now, there are various ways to configure networks. It depends on what you're trying to accomplish. You may want to span a VLAN like this across multiple switches, or you may decide not to do that, and you may, as an example, put this PC in VLAN 2 and this PC in VLAN 3, and then you could use routed ports on the links between the switches. So I'll show you those kind of options in this series of videos, but to keep it simple, what I'll do initially is configure PC1 and PC2 in the same VLAN, let's say VLAN 2. We'll configure them with IP addresses like 10.1.2.1 and 10.1.2.2. We'll have to configure these links as trunk ports so that the traffic can be sent from one PC to the other. These will be configured as 802.1q trunks. Now, in these videos, I'm not explaining all the theory of VLANs and trunking and so forth. I just want to show you practically how to configure Aruba switches. You can have a look at some of the other videos on my YouTube channel if you want to see theory of networks. Okay, first thing I'll do is configure the link between the two core switches as a trunk. We'll test that we can ping from one switch to the other, and then I'll configure these two ports as trunks and then configure these two ports as access ports in VLAN 2. The native VLAN in this example will be VLAN 1. Typically, what you do is you would configure the native VLAN on an 802.1q trunk as a separate VLAN. But we'll just use VLAN 1 for the moment. That's the default. Okay, core switch 1. Username is admin, no password at the moment. Core switch 2, username admin, no password at the moment. Okay, core switch 1. Username is admin, in this example, no password. Show run shows me the configuration of the switch. You can see the IP address of the switch is 10.1.1.101. Core switch 2, username is admin, password is blank. Show run. Configuration, IP address on VLAN 1 is 10.1.102. Can switch 2 ping switch 1? Yes, it can. So I can ping from one switch to the other, but if I look on switch 1, show LLDP neighbors, what you'll notice is the second core switch is connected to port 115, show run interface 115. You'll notice that routing is not enabled on this port and it's in VLAN 1. Show interface brief shows me that this port is running at 100 gig and it's configured as a switch port rather than a routed port. It's configured in VLAN 1. So what we want to do is go onto that interface and we want to type VLAN trunk allowed. And in this example, I'll just allow all. If I type do show run interface 1/1/5, what you'll notice is the default VLAN is 1 and trunking is configured to allow all VLANs. Type end show interface 1/1/5. You can see the interface is up A DAC cable is connected, running at 100 gig. Native VLAN is 1. All VLANs are allowed. Now, rather than doing it that way, I could use the command show interface 1/1/5 brief. You can see that this port has a native VLAN of this. It's configured as a trunk. That's the type of cable used, 100 gig Ethernet. It's enabled and it's up. So we need to do something similar on the second switch. Show LLDP neighbor. We connected to that switch on 1/1/5. So interface 1/1/5, VLAN trunk allowed all. Show interface 1/1/5 brief. Interface is configured as a trunk. So we should be able to ping switch 1, which we can. Show LLDP neighbors. We can see the neighboring device. We can once again ping that switch, and the port is configured as a trunk. Okay, so that is this link. Okay, so we've successfully configured this port as a trunk. Let's do the same on these links. I need to configure the interface on the 8360s and then the uplinks on the 6300s, and then I need to make these access ports. Okay, so show LLDP neighbors. We have this port and this port connected to 49 and 51 on the 6300. Now, in a previous video, I showed you the physical cabling. This is using a breakout cable. So show interface brief. What you'll notice is 1/1/9 is a single cable, but it's connected to two 25 gig interfaces on the 6300s. So conft interface 1/1/91 VLAN trunk allowed all. Do the same on the other port. Show interface 1/1/9:1, and let's use brief rather. You can see that that's trunking. Same on the other interface. So 1 and 2 are both trunking. Okay, I'll save the configuration of this switch. Let's do the same on switch 2. So show LLDP neighbor. Same ports are connected to switch 2. So interface 1/1/9:1 VLAN trunk allowed all. Do the same on the second port. Show interface 1/1/9:1. And again, I should use brief. And I'll do the same on 2. Okay, so now that I've done that, I'll do a write mem of the core switch. Okay, so I've configured the two core switches. Now I need to configure the access switches. So first access switch. Show LLDP neighbor. These two ports, 49 and 51, are connected to the first 8360 switch. So conft interface 1149 VLAN trunk allowed all. Do the same with 51. Now, once I've done that, I should be able to ping from the access switch to the core switches. So show interface 1/149 brief, and I'll do the same with 51. Just want to confirm that I've done it right. This port is configured as a trunk. This port is configured as a trunk. Show IP interface brief. This switch has this IP address. Can I ping the first core switch? Yes, I can. Can I ping the second core switch? Yes, I can. So I'll do a write mem on the switch. Second switch. Username is admin. What you'll notice is the configuration is very similar, and this is why you often want to use automation once you understand how things work, rather than continually typing the same commands. But for this demonstration, it's fine to do it manually, just so that we can understand what we're doing. So this switch is exactly the same ports. So VLAN trunk allowed all on 49, and on 51 allowed all. Show interface 1/149 brief. that's a trunk, and that's a trunk. Show IP interface brief. Can we ping the first core switch? Yes, we can. Can we ping the second core switch? Yes, we can. Can we ping the second access switch? So that ping 10.1.1.104 is a ping from the second access switch with IP address 10.1.1.104 to the first access switch through the trunk port. So we are pinging this way from 104 to 103 through this trunk port, and this trunk port. So traffic is going through those links. Now spanning tree will be blocking ports. So let's see which ports are actually forwarding. So on this access switch, show spanning tree. What you'll notice is 1/1/1 is forwarding. That's a port to a PC. But if I scroll down, and let me make this slightly smaller because we have a lot of spanning tree output. So do that again, show spanning tree. What you'll notice is 1/149 is the root, that port is forwarding. 51 is an alternate port that's blocking. So at the moment, we are actually only using one of these uplinks. This one is blocked, 49 is permitted. And that's why, rather than doing it this way, what we may want to do is use link aggregation and aggregate these links, or use routed ports rather than switch ports, so that we can use OSPF to load balance across the links. For the moment, we won't do that. We'll use simple VLAN configuration. We'll configure link aggregation later. So those two ports are trunking now. Next step is to make these access ports. Then we need to configure IP addresses on the PCs and prove that we can ping from one PC to the other through our infrastructure. Okay, so on the first access switch, show interface brief. This port is where the PC should be connected. So I should actually have a PC connected to that port. At the moment is not showing connected. And the PC that's actually connected to that port is this Dell laptop. So if I go to control panel, network and internet, network and sharing, change adapter settings. It looks like the cable's not connected, so I'll have to go and connect that. But for the moment, I'll configure the port and then I'll make sure that the cable is connected. So first thing I need to do is configure a VLAN. So I'm going to create VLAN 2. If I type show VLAN, notice we've got two VLANs. On the second switch, I haven't created a VLAN yet. So if I type show VLAN, notice there's only VLAN 1. VLAN 2 hasn't been created yet. So conft VLAN 2. So I've created the two VLANs on the two switches. But once again, if I look at port 1/1/1, the port is down. It's in VLAN 1. So interface 1/1/1, VLAN access 2. Put that into VLAN 2. So again, show interface 1/1/1 brief. You can see that the port is now an access port in VLAN 2. I'll do the same thing on the second switch. Do show interface brief here. You'll notice that this port is up, running at a gig. That's actually this laptop that I'm working on, my Asus laptop. If I go to Network and Sharing Center, change adapter settings, what you'll notice is this port is connected at 1 gigabits per second. So what I could do while I'm here is change the IP address. So let's put this port into the right VLAN and then I'll change the IP address. So VLAN access 2. Show interface 1/1/1 brief. This is an access port in VLAN 2. So on my laptop, if I configure this, go to properties, TCP IP, and I'll make this 10.1.2.1/24 mask. Default gateway will be 10.1.2. And in this example, I'll just make it 101, which is the core switch. DNS server, I'll make 10.1.1.50 as an example. That will be a server that I need to configure in my topology. So I don't have that server configured yet. Now I need to configure the default gateway of my core switch. So on my core switch, let's say here, do show VLAN. I don't have VLAN 2 configured yet. So I need to configure VLAN 2, and then I'd need to type interface VLAN 2 and configure the IP address of the switch. So something like that. So show IP interface brief on this switch. You'll notice it's got 2 IP addresses configured. So on my Asus laptop, IP address of this PC is 10.1.2.1. On the Ethernet interface, I should be able to ping 10.1.2.101, which is my core switch. That's assuming that everything is configured correctly. Okay, so let's do some troubleshooting. Ping 10.1.2.101. Can we ping ourselves? Yes, we can. What I'll do while we're here is configure the VLAN on switch 2. So VLAN 2 on switch 2, interface VLAN 2, IP address 10.1.2.102/24. Can this switch ping 10.1.2.101? Yes, it can. So the 2 core switches can ping each other. Can the PC ping the first core switch? No. Can it ping the second core switch? Yes, it can. So at the moment, I can ping this switch. This PC has an IP address 10.1.2.1. This switch has an IP address 10.1.2.102. This switch has an IP address 10.2.101. That may be a spanning tree issue, or there may be a problem here. I'll need to check why I can't ping from this PC to that switch. So let's do some more troubleshooting. I made the mistake of not having VLAN 2 configured on the second core switch, and I also just needed to wait a bit for spanning tree to converge in this topology. Next thing I need to do is configure an IP address on this PC, and I need to make sure that that's plugged in properly, because at the moment that's showing down, and then I should be able to ping from one PC to the other. Okay, so on my Dell computer, this is the one connected to the first access switch. Change adapter settings, configure the IP address here as 10.1.2.1. Put the subnet mask in. Default gateway will be that. And DNS server I'll set as that. Now it's going to complain about multiple default gateways. Now that can be a problem in Windows because I've got multiple default gateways. I am controlling this laptop through the Wi-Fi interface, so I may need to remove the default gateway off the Wi-Fi interface. But for the moment, that should be fine. So I'll open up a CMD prompt. I'll make this bigger. ipconfig. I'm not seeing an IP address on my Ethernet adapter. I need to plug that in. So I'll quickly go and do that now, and then I should be able to ping from one PC to the other. Before I do that, I'll just save the configurations of my switches. Good practice to save switch configurations. Okay, so I've plugged in the cable. In command prompt, ipconfig, you'll notice the IP address is displayed now, ping 10.1.2.101. Can we ping the core switch? At the moment we can't. Let's make sure that the core switch can ping itself. Yes, it can. Can it ping PC1? Yes, it can. So it is able to ping the PC. The mistake I made is, let's check if I configured the wrong IP address. Yes, I did. So this PC's actually got the wrong IP address. So let's do that again. Can I ping the core switch? So that was a really dumb mistake. I configured the wrong IP address on PC2. I gave it PC1's IP address. So that may take a while to sort itself out. So on PC2, let's try and ping PC1. I'll ping the second core switch. I can do that. Can I ping the first core switch? Yes, I can. Can I ping PC1? Still can't. So this is a good example of making sure that you configure stuff right. ipconfig on this PC, can it ping itself? Yes, it can. Can it ping the core switch? I'll set that going permanently. And what I do find that helps sometimes for troubleshooting, if you don't know where the problem is, configure an IP address on your access switch. So on the first access switch, show VLAN. I've got my 2 VLANs. Show IP interface brief. Only one IP address is configured, so I'll configure a second IP address. This is switch dependent. Some switches won't allow you to configure both IP addresses. But show IP interface brief, I can see both those IP addresses. Can I ping the core switch from this switch? Yes, I can. Can I ping the PC? At the moment, I can't. So let's see if it's something else that's causing the problem. What I'll do is disable that interface, enable it. And one thing I need to do is check that it's actually up on the switch. And you can see I made another mistake here. I plugged it into the wrong port. It's connected to port 2 rather than port 1. So I've made multiple mistakes here. Show run interface 111. I configured that interface in VLAN 2, but the PC is connected on port 2. So what I'll do, rather than running back to where my equipment is, I'll put this port into VLAN 2. And notice as soon as I did that, the PC can ping the switch. So just to summarize, this PC I configured with the wrong IP address. It needs to be 10.122. So I've fixed that now. This PC needs to be configured with that IP address. The mistake I made is I put the cable into the wrong port. This is actually on port 112 and this is on 111. So I'll go and fix that, but I showed you now that by simply moving the port from VLAN 1 to VLAN 2, pings started succeeding. These ports are configured as trunk ports. So to summarize, let me show you the configuration. On the first access switch, this port is configured in VLAN 2 as well as this port. So that's fine for this demonstration. I just need to move the PC to port 1 once again. If I want to follow my diagram, show run interface 1/1/1. This is the second switch. That's correct. Port is in VLAN 2. Show run interface 1/149 and 51. Those are the uplinks to the core switches. They are configured as VLAN ports. The same on the first access switch. Configuration is exactly the same. They configured as trunk ports. And then on the core switches, same kind of configuration. Show run interface 119. And that should be 1 and 2. Those are the ports to the access switches. And then if I look at 5, it's configured as a trunk port. Okay, so on the PC, can we ping from one PC to the other PC? And the answer is yes. PC1 can ping PC2, and on PC2, can we ping PC1? And just to prove the point, so I'll start Wireshark on PC2. I'm going to capture traffic on Ethernet 5. That's the connection to the Aruba switches. So start capture. We're seeing a bunch of traffic. There is Microsoft traffic being sent into the network. We're seeing Aruba spanning tree messages because spanning tree is being used in the network. But what I'll do is filter for ICMP. And then what I'll do is on PC1 ping PC2. And as you can see, PC1 is able to ping PC2. PC1 has this IP address 10.121 on the Ethernet interface. And on PC2, we can see the ICMP messages from PC1 being received on PC2. And on PC2, if I pinged PC1, the pings are succeeding, and we see those ICMP messages in Wireshark. Okay, so I showed you how to configure VLANs in this network. I also made a few mistakes, showed you some troubleshooting options. One thing I haven't done is configure a VLAN IP address on switch 2. So let's do that. So on the console of switch 2, show IP interface brief, it only has one IP address, interface VLAN 2, IP address 10.1.2.104/24. Can I ping 10.1.2.104? Yes, I can. Can I ping the core switches? Yes, I can. Can I ping switch 1? Yes, I can. So I'll save the configuration of my switches, and there we go. Hope you enjoyed this video. If you did, please consider subscribing to my YouTube channel. Please like this video and click on the bell to get notifications. That really does help me. What do you think of these videos? Hopefully you're enjoying them.